All right, so here we go. So this is section 1.1. This is the first one. So this is exactly what your homework's going to be like, which is different numbers. So we're starting with the distributive property. Do you remember how that works? Like when you have a number in front of parentheses, what does that number do? Yeah, it has to distribute. You know, like I'll distribute a test on test day. I'll pass out a test to everybody. We distribute that 5 to both those terms, don't we? It hits the 2a and it hits the minus 7b. And it's going to multiply. So 5 times 2, 10, and the a just stays right by it. Minus, and now the 5 also hits the 7. 5 times 7, 35, and the b stays there with it. Again, if you're rusty on your times tables, feel free to use a calculator. Tests, homework, everything. Nope. Calculators are fine. Not cell phones, of course, on the test, right? Cell phones are fine today, but on test day, you can't use a cell phone because you could call out for answers in the middle of the test. So you got to have a calculator on test day, so make sure you have a calculator. All right, next one, number 2. Stop me if you have questions as we're going. That's all there is on number 1, just distribute. Number 2, there's fractions, huh? That always makes things worse. Fractions are always much more tricky. So let's take that minus 5 and go boom, boom. We're going to multiply both those. And so what happens? Minus 5x. And then the minus 5 also hits the 2. Negative 10. This is making sense so far. By the way, notice I dropped the parentheses after I multiply. So parentheses are there indicating multiplication. And then, I'm not done yet, there's more to do. As soon as you multiply, then the parentheses drop off. That minus 5 went to both. Now the minus a half is going to go to both, isn't it? So what happens? Well, let me do it slowly. Well, I guess this was it. Yeah, what's half of 10? Yeah, so it'll become minus 5x. And then what's half of 4? 2. Would it be right to write that? I've done something wrong, haven't I? What's wrong right there? Yeah, so what should it be? It should be minus 2, right? We all see in that? Because, now why is it minus? There's a plus here. Because that minus belongs to the half, doesn't it? Any sign, plus or minus, that's in front of a number or fraction or a letter, that's their baby. It goes with them wherever they go. So that minus that's in front of the half has to travel with it. So negative a half times the plus 4 is negative 2. Now, we're not done here. This one, the multiplying part is over, but now we go into adding, subtracting mode, don't we? So the parentheses are gone. We've done the multiplication, but now we have to do adding, subtracting. And how does it work with adding, subtracting? You combine like terms. Do you remember some of that? So like the minus 5x and the other minus 5x are going to combine together. So what's that going to be? Negative 10. And it's not x squared, is it? Why not? When would it become x squared? And if you're multiplying, we'll do some more of that in a minute. When you're multiplying x's is when the powers change, huh? But if you're just adding, subtracting, then you just add and subtract the numbers in the front. You don't mess with the x's, just leave them as they are. Right? And that's like losing $5 and losing $5 again. You've lost $10. Huh? That's all we did there. And then negative 10. So you lose $10 and you lose $2. You lost $12. And that's it. We're done. So first we multiplied. So first we took the number in front of the parenthesis and multiplied. And then we gathered like terms on that. Questions on that one? Is that making sense? All right, let's try number 3 there. What needs to happen on number 3?
On number 3, you have to do the top part before you hit the bottom.
Yeah, you got to do the top and the bottom separately, huh? Yeah, so let's do that. Exactly. So let's start right here. So we have minus 2 plus, what's 1 squared? It's 1 times 1, huh? It's just 1. Right, you good there on that? 1 squared is 1 times 1 is just 1. Nothing. Doesn't change it at all, does it? Now, what about minus 3? That's a good idea. Yeah. All right, so yeah, so this one up here, minus 2 plus 1 squared, minus 3 over minus 5 plus 2 minus 1. Yeah, good idea. Let's do that. Okay, so yeah, so then minus 2, that's just going to stay minus 2 plus 1 squared is just 1. Now what happens right here with minus 3? Yeah, the two minuses become plus, don't they? It's plus 3. And then down below, minus 5 plus 2 minus 1. Now let's just combine them, on the top and the bottom. So the top, what is that going to be? Minus 2 plus 1, negative 1 plus 3, 2. Do that right? Yeah. Bottom, minus 5 plus 2. If you lose $5 and gain back 2, you're down 3, and you lose 1 more, you're down 4.
Or you combine them like I always do. 1 plus 4 minus 2.
Yeah, any way is good. Now, is that our final answer? Can we leave 2/4?
No, it is a right answer, but you can
reduce it.
simplify even more.
Yeah, so we got to reduce it. So divide by 2, top and bottom, yeah. So it's half. Now, do you have to put the minus on the bottom? Is it okay if you put it like in the front? Is that the same thing? What if you put it in the top? Is that the same thing?
Yes.
Those all the same thing?
No.
The answer is yes. They're all the same thing. Let me write all 3 of them. Any of those is fine. Yeah, why? Well, because one negative sign is negative, no matter where it's at in the deal. Now, 2 minus signs would be different, right? If I had minus 1 over minus 2, 2 negatives would actually be what? Positive. That'd be the same as positive. So that's not what we're talking about. But yeah, any of these 3 are fine. It doesn't matter where the negative is. You have one negative, top, bottom, or front. It's all the same thing. It's just negative fraction. Yeah.
Do you mind explaining how you got the
What I was doing on that is I was just adding up and subtracting these numbers, the top and the bottom separately. So I literally just did the numbers. I just said, just thought about money, gains and losses. If you lose $2 and you gain 1, you're down 1. And then you gain 3, now you're up 2. So positive 2. So I just added and subtracted those numbers on the top. And the same thing on the bottom. I said, well, if you lose $5 and you gain back 2, that's a negative 3. And lose 1 more, that's negative 4. So I just added and subtracted. You can use calculators also for that stuff.
They take you to Vegas.
All right, we good there? Is it all making sense?
A little bit.
All right, let's take a look at number 4. So we got a little bit of words here. Mr. Smith and Mr. Stein were driving to a business meeting 220 miles from their office. Mr. Smith drove the first Y miles, and then Mr. Stein drove the rest of the way.
Oh.
Write an algebraic expression for how many miles Mr. Stein drove. I wish they didn't make them both S's. That wasn't very good.
Oh.
But anyway.
3 minus y.
Okay, so how are we going to do that? So the business meeting is 220 miles away. They had to drive total 220, right? Mm-hmm. And the first guy drove Y miles. So how far did the second guy have to drive?
Going on. So you have to make an expression. So that means.
So one thing I learned about word problems where they use letters, a long time ago, I learned, and I think it's true for everybody, that it really helps me to stick in a number instead of letters. A lot of times I'd be reading word problems in the millions of math classes I had to take, and I'd be like totally confused, and I would just say, okay, I don't know what I'm supposed to do with that Y, but just suppose it's a 10. I would just make it a number, any number you want, just make it a 10. I think way better with a number than I do with a letter. Then I think, okay, so we have this 220-mile trip, and the first guy drove, instead of Y, say 10 miles. First guy drove 10 miles. So how far does the second guy have to drive? And how are you coming up with that answer? We take 220 and we subtract the 10, huh? So now it's not really 10. What's the 10 supposed to be?
Y.
So the answer is 220 minus y. So we think better with numbers than we do with letters. Just think it out with a number and then stick back in the letter again. That making sense? So it's 220 minus y. It's easy to get those reversed and accidentally put the y first. You probably knew it was subtraction.
Yeah, because
But-
if you put the y first, that means it would be wrong answer.
Yeah, that's right. The order matters, doesn't it? You got to take the total first, huh? 220 is the total, and subtract the amount the first guy did.
So,
Yeah.
where is it?
Yeah. So you stick in numbers, and you'll find you think a lot better. Can you want to try number 5? See if you can work out. Usually, some of those are big numbers. Use your calculator. 9 to the third power there. Well, what does that mean when they put a little third power on it?
It's just like,
9 times 9 times 9.
Yeah, 9 times 9 times 9. Or you can use the power button in your calculator if you know where that is. Or you can just go 9 times 9 times 9. So see if you can work out the top, work out the bottom, and get an answer. I'll finish it in a second.
it's a ring.
All right, let's take a look.
But that can be simplified too.
So the top,
Oh.
4 plus 1, is going to be 5. And 17 minus 5 is going to be 12. The bottom, 9 to the third power, 9 times 9 times 9 is 729. So we get that. That's a times up there, not a decimal. And then we simplify that, and we get 60 over 10. You can divide it in the calculator or by hand. 6. Questions on that?
Yep, that's it. That's what I'm doing. Hooray! I'm not as bad as I thought I was.
All right, let's go on to number 6. So fractions are always important to go over slowly. All right, so we have on number 6, we have that fraction 2/7 in front of the parentheses.
So we have to write that into a fraction.
In fact, if you don't mind, I'll bring it up. I'll have to erase some of the other stuff, but move this up here so we can all see it well. 2/7 times 35z plus 35. Okay, so now really you could just use a calculator, and that's fine. But I'm going to go ahead and do it slowly by hand. But if you want to just take your calculator and go 2 divided by 7 times 35, you'll get 10, and that's great. But I'll show it slowly. 2/7 times 35z plus 2/7 times 35. That 2/7 goes to both, doesn't it?
Oh, I have the things written.
Good so far? So anything in front of parentheses multiplies both the things on the inside. I haven't actually multiplied them yet. I kind of just placed it, and now I'm going to multiply.
Isn't it supposed to be 35z over 1?
Yeah, good point. That's really what we should do, is put that over 1. Yeah, whenever you have a whole number interacting with a fraction, that's the way to do it.
Okay.
Put it over 1 and make it look like a fraction. It's just easier that way. Yeah, now again, your calculator will do this. You can just take your calculator and go 2 divided by 7 times 35, give you 10. Or I'll show you the by hand way. Do you remember what the rule is by hand here that you can, because in a little bit there's going to be letters, so we do need to learn the actual rule also. Do you remember you can cross-cancel? Do you remember cross-canceling?
And that's what this is, right?
Yeah, it's
'Cause
exactly
7
what it
goes
is.
into 1,
That's it. So the 7 goes into 35,
5 times.
and then you cross them out and put a 5. It just divided in there.
Mhm.
And so 7 goes into 35. They both cancel out, and it leaves 5. And so what's left then? What numbers are left? A 2, a 5, and a z. 2 times 5 is 10z. Again, your calculator will tell you that.
Plus,
Now let's do the other one. It's going to be the same thing. Put the 35 over 1. Make it look like a fraction. 7 into 35. 5 times.
that's 10z plus 10.
And then 2 times 5. There it
And
is.
that's the answer.
And there's the answer.
Yeah, because I know you can't really take calculators everywhere you go.
Question?
We don't have to use it like that exactly, right?
No, it's if you just hit the buttons on your calculator, that's fine. Or did you multiply the top first and then divide? That's fine too. You made 70 divided by 7. That's great. Yeah, those ways are fine.
So you can teach us how to do the calculator way too?
Yeah. So literally on the calculator, you would just hit 2 divided by 7 times 35 equals, and it'll pop you right to the 10. Yeah, a fraction just means divide,
Okay.
and then you multiply by the 35.
2 divided by 7 times 35.
Yep, that'll be 10. There it is.
Stupid thing.
All right. Number 7. Ah, there's another one. That's a good one to practice. Let's try that one. It's very similar to the last one. Got to distribute, and we've got fractions. This one okay? Let's take a look. So that 30 is going to go boom, boom. It's going to go to those two. So here we go. So 30 times 2/5 x plus 30 times 5/6. So first off, I just place the 30 next to both those because that's what the number in the front of the parentheses means. And then what do you got? What do you do when a whole number is interacting with a fraction? Yeah, make it look like a fraction, right? Make it easier for us. Put the 30 over 1. Haven't changed anything, have we? 30 divided by 1 is still 30. Now, what rule do we follow? Cross-canceling. Yeah, or you could use the calculator too. But 5 goes into 30 6 times. They cancel out, and the 6 is left. 6 and 2 and x are left in the first spot, which is 12x. Good there for the first one. And then, same thing here, 30 over 1. And what happens? 6 goes into 30. 5 times 5 times 5. 25. There it is. And that, yeah.
So, when you multiply fractions,
Show that. Really good questions being asked. Let me go back to the 30 times 2/5 x. Yeah, that's an excellent question. The question is, okay, 30 over 1, right? We put it over. Let's redo it. And let me answer by redoing it. And so his question was, you probably heard somewhere, with fractions, don't you just go straight across? Yes, you could do that as well. That's actually true also. So what if I did that? Just go straight on the top and straight on the bottom. So 30 times 2, what would that be? 60. And 1 times 5 on the bottom? 5x is still there as well. And then, what is 60 divided by 5? You can use your calculator. 60 divided by 5 is? Same answer. So it's two ways of doing the same thing. Cross-canceling is just simpler numbers. Do you see that? That's why we cross-cancel. So they both resulted in the same answer. But see, on this one, I got to a 60. That's a lot bigger number. Whereas over here, when I cross-cancel, I made the numbers smaller. So all cross-canceling is simplifying early while the numbers are still small, instead of simplifying later when they're bigger. They're both right. This is just keeps the numbers a little simpler. Did you have something else?
So, there are two different ways of solving the problem. If you have to choose one, which would you recommend you do? So that way,
Yeah, the cross-canceling keeps the numbers a little smaller. So cross-canceling is just early simplifying. That's all it really is.
So with the other way, the 60 over 5, that takes an extra step. Like if you're having to do a speed test.
Yeah, you're right.
Test,
yeah.
it was an extra step.
It's an extra step and bigger numbers. Yeah. But it's still true.
So you'll probably, 9 times out of 10, you might get that answer wrong if you do something like that.
Get bigger numbers, yeah. Without a calculator, you might. Because numbers, sometimes they get really big. Yeah. Yeah, so so I want you to see there then that all cross-canceling is simplifying. You're just dividing top and bottom. That's all you're doing. And it's nice to simplify early before the numbers get big.
That's probably what happened to me when I was younger.
Good. All right, let's try on number 8. They're giving us an expression, u squared minus 2u plus 4, and they're saying when u equals -3.
Oh.
So what are we going to do?
You're gonna put
You're
negative
gonna
3
plug
for
in
you.
u.
Yeah. There's one important rule, though. When you plug into a formula, you need to put parentheses around the number you're plugging in. So I'm going to put parentheses around this -3, and I'm going to plug it in right there and right there. So it'll become
So start off.
parentheses -3 squared minus 2 parentheses -3 plus 4. I'm making sense so far? Now let's work out the pieces. What is -3 squared?
That's 9.
Yeah, it's +9, isn't it? Because it's -3 times -3, and two negatives multiply to be positive, don't they? So that's positive 9. And what's negative 2 times negative 3? Positive again, because again, 2 negatives make positive. Plus 4.
And 19.
Yeah, because 6 and 4 is 10. You know, and 9 is 19. There we go. So what did we do? We plugged in negative 3 for u. Worked it out. Worked out the expression. All right, time for another word problem. Number 9. The following expression gives an approximate value of the total average credit card debt in the United States household in dollars T years after 1995. So there's a little formula they're giving us right here. Use this expression to predict what the total average credit card debt was or will be in the year 2020. That's our year. So this year, by the end of the year, what will be the average credit card debt according to that formula? Now, what does that mean I'm supposed to do exactly? So this is about reading those words carefully. And the hint is great if you can see that hint down there. The key here, the hint reads, is to keep in mind that T is years since 95, meaning years after 95. This is something they'll do all the time in math, science, higher level word problems, is they'll let T be years after a certain year. Where's it? Right here. T is years after 1995. In other words, if T equals 1, what is the year? 1996, because that's 1 year after 95. What if T is 2? What's the year? 1997, because that's 2 years after 95. So in other words, 95 is like our starting point. And T is how many years from that starting point. Basically, 95 is when they made the formula, in other words. And then they map forward from that point in time. So they do that all the time in math science formulas. If you take biology, chemistry, economics, it's real common practices to put that kind of expression. So, okay, so what? So what's their question then? They're saying the year 2020. So how can we use this formula? We need to know what T to plug into that formula. We don't plug in 2020, do we? What do we plug in?
2020 minus 1995.
Yeah, we got to find out how many years it is after 1995. Because T, remember, is years after 1995. So, if I take the year 2020, our current year, and I subtract 1995, what is that going to be, 25? 25, so that's 25 years after 95. So plug in T equals 25 to this formula right there. And then let's work it out. That's what that formula is saying. Plug in the T, and I'll tell you the answer. So we're going to plug in.
Isn't it 399?
Oh, yeah, thank you. I messed that up, didn't I? 399, thank you. 399 times T plus 5380. Tracking with me? What's happening? So the first thing we did is we said, okay, this T is however many years after 95. So if it's the year 2020, I got to subtract. It's 25 years after 95, and then plug that in for T in that little formula they gave us. So I plug in 25 for T, and then I would just use my calculator. Those are big, ugly numbers.
Yeah, that's about right.
So 399 times 25, I have no idea. And then add 5380. Anybody got an answer?
Yeah.
15,355.
Oh, 15, what was it? 15,
350.
355. 15,355. Is that the average credit card debt?
That's about right.
That's a lot to have on a credit card. All right.
People like to travel.
Is that good? That making sense? How we did that? So we had to find the T. That was years after 95 by subtracting 25 and then plug in. And then just use your calculator on that. If you're having any trouble on the calculator, grab me after. Be glad to help. Every calculator is a little different. I'm sure I can quickly, easily help you, but they're all different. So grab me individually. Questions on that one? How we doing? We good? Keep moving. Number 10. So another formula one, yeah, that,
You like using those.
yeah, let's move on. I'm going to do the harder ones. I'd rather skip. That's the same as one we did earlier. I'm going to skip number 10. Let's go on to 11. Yeah, 11 will be more worth our time, I think. Length is 8, width is 10, height is 6. There's our formula. So just plug those in.
Oh, sure, that's easy.
Just pop them right in there. Use your calculator if you want, or do it by hand, either way. Plug those in and see if you can find those different numbers. So length 8, that's going to plug in right there. And there, huh? 2 places for that. Plug in the width, plug in the height.
Hey. Oh, no.
So I'll plug in the length of 8 and the height. What's the height? 6. So remember, put parentheses around things you plug into formulas. And the width is 10 and the height is 6 and the length is 8 and the width is 10. And then, yeah, I would use my calculator. Those are big numbers. But 96, 120, 80, 296. Good there.
Hey, okay,
So just plugging into the formula and cranking those out.
because LH was,
So L is length and H is height and W is width.
oh, that's what I did wrong. Okay. Because, so it's not WH. Those are two
Right.
different-
Each individual letter is a different number.
Okay, that's what.
Yeah, you're right. Each letter is a number. All right, want to try number 12. There's the Celsius Fahrenheit conversion formula. The same kind of thing. Plug in there. What answer are y'all getting? Right, good. So we take that 41 and we plug in right there for F, because that's the Fahrenheit temperature. So we plug that in, so we get 5 times 41 minus 32 over 9. Is that good there? And then that's 5 times 9 over 9. You could just cancel the 9s. That'd be the quick, instead of making it 45 in the top. Either way. It's good either way. A little quicker that way. The answer is 5. So 41 degrees Fahrenheit is 5 degrees Celsius. Is that good? Questions on that one?
Wait a minute. By the 5 and the 41.
Oh, good question. Yeah. I do this so now I don't think about it. Yeah, good question. Yeah, why didn't I take the 5 and go boom and boom? Well, you could have. It's not wrong. It's okay. But the reason it's better and quicker to do it this way on this one is because I can. Now, what do I mean I can? When can't you? When one of them's a letter. Let's look back. Let me show you. Look back. Where was one of the ones that was a letter? I know there was one. Yeah, look back here at number 6. So a really good question is being asked. Why didn't I look back at number 6? Remember how we did number 6? we took that 2/7 from the outside and we went boom and boom. I didn't add them first. I went ahead and distributed. Whereas all of a sudden on this other one, I'm doing the inside first. Why? Well, because I can't. I'd always prefer to do the inside, but I can't do the inside back here in number 6 because they're unlike terms. One has a letter, one does not. You cannot add these and make them 70Z. That's not true. If the second one also had a Z, then that would be okay. Right? Then you could say 35Z and another 35Z, and that'd be 70Z. But when one has a letter and one does not, they're oil and water. No mixing. No, they're not like terms. They can't come together. So I simply could not add the inside. I had no choice but to take that 2/7 and place it in front of each one, distribute. Whereas over here, when they're both just plain simple numbers, it's quicker to just subtract them. Now, it's not wrong. Watch. Let me just show you the other way is still true. It's just way longer. If you did distribute, 5 times 41, would that be 205?
Yep, that's right.
5 times 32, yeah, 160. And then that'd be over 9. Yeah, and then if you subtracted those, you'd get 45 over 9. You'd get the same answer. Math always works, as long as we don't break the rules. But that's by far not an easier way, huh? It's big old numbers like 205. Yeah, so if you can subtract the inside, meaning if they're both just numbers, then just go ahead and do that. That's quicker.
Yeah, so we got 9. The 41 minus 32 is 9.
Yeah, that became this 9. Exactly.
So how do we get to the 5?
And then these just divided. Remember when the numbers are the same top and bottom? Yeah, I just canceled them out. That's just cross-canceling,
Yeah, I
basically.
keep remembering, as long as at the beginning, if that was a 5 over 1.
That's right. It's 5 over 1.
Okay.
Good. Other questions on that one?
See, that's why I keep, if I don't put that down, my whole thing is.
All right. Time to solve equations. Things are changing all of a sudden on number 13. So notice 13, 14, 15. Notice what's different about these three from all the other ones we've done so far. There's equal signs in the middle. Do you see that? These are equations. Are they big enough for you? Let me write them over here a little bigger. I wonder if we're going to have room. Yeah, let me put them up here for you. Minus 4x, minus 4, parenthesis, x plus 8 plus 1 equals 4, parenthesis, x minus 8. Okay. So we have an equal sign. This is an equation. These two things are equal. So that's it. I like to put a line. You don't have to, but I think that'll be nice just to see it separated really clearly. We have a left side and a right side, right? And so if you have two things that are equal, and you do the same thing to both of them, they'll still be equal afterwards, won't they? Of course. It's called the principle of equality. We all sense it's true. That's the idea here. So this is totally different than the other ones. The other ones, we didn't have two sides. We didn't have an equals in the middle. This is an equation. The other ones were expressions. They weren't equations. An equation, it's got an equals in the middle. It's got a left and a right. This is an equation. We're trying to solve for x in the end. We want to know what number could x be to make the left side equal the right side. That's what we're figuring out. All right. Enough said. Let's dive in. We know what to do with parentheses. Whatever's in front of the parenthesis goes boom and boom. Right? So that'll be minus 4x minus 32. And now, does the minus 4 also hit the 1? No, because he's not in the parentheses. So the 1 just stays 1. And then the 4 on the other side does the same thing. 4x minus 32. Good so far? So we got rid of, whenever you multiply, then you get rid of the parentheses. So we did the multiplying, got rid of the parentheses. Now, I have 4x on one side and negative 4x on the other. What do you do? Do you remember from earlier algebra courses? When you have x's on opposite sides of the equal sign. Do you know? Yeah, you got to get them on the same side, don't you? Basically, you've got to get rid of one of them. It doesn't really matter which one. You can get rid of either one. You don't want two of them. You want to just get rid of, because you only want x in the end. Yeah, let me tell you what our goal is. When all is said and done, we want x all by itself, alone, left side, right side, doesn't matter, whichever side. But on one side, x all alone and whatever number on the other side, and that'll be our answer. That's what we're trying to do. We're playing the I want to be alone game. X is yelling out, X is a big loner. Like, what if I yelled out all of a sudden, I want to be alone in here? You guys would think, he's strange. We'll let him be alone and you'd all leave. That's kind of like what X is doing. X is yelling out, I want to be alone on my side of the wall. Everybody get to the other side. So, okay, so how do we get X alone? Well, first off, if you have it on two sides, you don't want that. You got to get rid of one of the sides. Usually I'll go to the lower one, and -4 is negative, so it's the lower one. And I'll do the opposite. That's what will get rid of it. So what's the opposite of -4x?
Positive.
Exactly. So I'm going to add 4x. But whatever you do to one side,
You have to do the other.
yeah, because if they were equal before and you treat them the same, they'll still be equal afterwards, won't they? Now I'm going to draw a line to show that I'm taking action on both sides and now showing the result of that action. The -4x and the +4x will simply cancel. That's why we did it, huh? To get rid of the x on one of the sides. What's left on that left side? -32 + 1. If you lose $32 and gain back $1, where are you at on your bank account?
-31.
Yep, I've been there often. All right, and then on the other side, we just combine things. 4x and 4x, 8x, and then you just bring down the 32. So we took a step towards getting x alone. X is still yelling out, I want to be alone over here. So get rid of this 32, -32, and get rid of this 8 so I can be alone. So what's my next step?
Same thing you did on the left side with the 4x.
What am I trying to get rid of?
You're trying to get rid of that.
Trying to get rid of the -32. So because we're trying to get x alone. So what's going to get rid of a -32?
Positive 32.
Add 32. Yeah.
And you got to do it on both sides.
And you got to do it on both sides. Add 32 to both sides. Cancels out. And what is the other side? If you lose $31 and gain back $32, you made some money. You're at +1. You don't have to put the plus, just 1's good enough. Now, the last step, X is saying, I want to be alone. He's almost alone. We just got to get rid of that 8. Should I subtract 8? No. How do you know? You're right. I don't subtract, do I? Because it's times, huh? So the opposite of times is divide. I got to divide by 8. Does everybody see that? Because that 8 is right next to the x. No symbol in the middle. That means times, and we're always doing the opposite of whatever's already there to get the thing alone. So the opposite of times is divide, isn't it? So I've got to divide both sides by 8. So that means like a bar. Divide, and whatever you do to one side, you got to do the other, because if they were equal before, treat them the same, still be equal. These cancel. And so what's left on the other side? 1/8. That's the answer. X equals 1/8. And they'll show you how to put a fraction into the thing. When you do that first intro assignment, it'll show you how to, it'll be really easy for you. Put in a fraction. So there's the answer. Questions on that one? That was our first equation we solved.
So,
Question?
so when you go 8, when you cancel that, is it 8 over 8 versus 1 over 8, or how is that at the fraction?
This one right here, you mean?
Yeah.
Yeah, those just canceled. So 8 and 8 just, when the same thing is in the top and the bottom, they just cancel out. So let me show you, let me give you a deeper reason why. What is 16 divided by 8?
2.
Beautiful. What is 8 divided by 8? 1. That's what really happened. This is really 1x.
Okay.
And what is 1 times x?
1.
Just
Or
x. That's what really happened. Yeah, I don't show the 1, just saving time. But yeah, good question. Really, 8 divided by 8 is 1, and 1 times x is just x. So we say they cancel out, but what we really mean is they divide and become 1. That's really what's happening.
Okay.
Yeah. All right, so I think that we should skip 14 and come back to it, because that's a pretty hard one. Let's do 15. That one's more like the one we just did. And let me write it on a fresh screen. 3, 5y minus 2. So let me put it up here. And let me get a little paper there. There we go. All right, so 15, 3. What was it? I already forgot. It was 5y minus 2 plus 6. Okay. 5y minus 2 plus 6 equals... And what's that? 6, 2y plus 3. 6, 2y plus 3. Is it minus 1? Yeah, minus 1. All right, there we go. So let's try that one. That's number 15, and we'll come back to 14. Same kind of thing. Put the wall in the center, I think might help you, just to keep the left and the right separate. So you know the name of the game. Y is yelling out, I want to be alone. So on one side or the other, you got to get Y alone. Give you a minute. Encourage you to, things are going to get harder and harder and harder. This is just the beginning. This will look like child's play in a month. So, and to help with that, keep yourself really organized and come straight down. People get in trouble in math and they start kind of going off to the side and they're calculating, they're writing stuff over here. And you know me, I've got pretty sloppy writing. I mean, I'm about as sloppy as they get. But I keep it big and I keep it separate. And so I don't make a lot of mistakes just simply by that. You can be as sloppy a writer as me and still you won't make a lot of mistakes if you keep it big and you keep it separate. I remember bugging my own younger son who's taking some of these classes now, and I'm like, John boy, write it bigger, 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 bigger. He's trying to write those tiny things. I made a mistake. So yeah, because you can't even see it. Make it big. So make it big and come straight down. So keep that equal sign. So here we go. So that's that'll really help you. So let's distribute this. 3 times 5, 15y minus 6. Other side, boom, boom. 6 times 2, 12y plus 18. Bring down the minus 1. Notice the parentheses are gone, huh? Right? You don't want parentheses there anymore. Whenever something from the outside of parentheses goes in, they drop. So they're gone. Okay, now, I would go ahead and just combine those right now. They're just 0, huh? Right. They're just gone. You just cross them out. It's just 0. You can write 0 if you want to, or I just cross them out. So what's on the left side? What's left on the left side? 15y. Just bring him right there. Keep the left on the left and the right on the right. Like don't. It'll be way better for you. Just keep it organized like that. On the right side, we got 12y. And what do these guys make? Plus 17. Good so far? Yep. So see how it's real clear what's happening on the left side and the right side? Okay, now what are we doing here? What thought should be in my mind?
Go with the smallest number.
Yeah, when you have the y's on opposite sides, try to get y alone, right? Our eventual goal is y's yelling out, I want to be alone. So we can't have y in 2 places, so we get rid of the lower one. Are you catching that? Let me in fact write that step. Subtract lower y from both sides. Actually, it really technically is okay to do the higher one. It really doesn't matter.
Yeah,
but
make sure you take the y with you.
Get rid of one of them. Yeah, but don't forget the y. Exactly. Yeah, that's a lot of easy mistake to make. So who's the lower one? The 12y. Here's an easy mistake to make, to go minus 12. That's not right. It's minus 12y. Now, how do you know? Well, just be clear. What is it you're trying to do right now? Are you trying to get rid of only the 12?
No.
Do I want the 12 to go away, but I'm happy with the y there? No. Remember, I don't want the y in 2 places. I'm trying to get rid of the entire 12y. So make sure you subtract the entire 12y. And whatever you do on one side, do on the other. Now, see how I'm writing it and I'm keeping it left side and right side really separate? You want to do that. In other words, you don't want to do this kind of thing. You don't want to go, okay, I'll subtract 12y and then 3y and then, you're going to get lost, especially when they get really ugly. This is nothing compared to how they will become. So keep it really organized, left side, right side. So minus 12y. See how I come straight down? That's not just Mr. Heron's technique. That's every math person. We come straight down as we do. We never go side on a problem. This keeps it organized. So now cancel, right? That's gone. Oh, and notice the line I put. You see this line? I think that'll really help you. It's just I'm totaling 2 things. That keeps a difference between what's there and the action I'm taking upon what is there. Do you see that? And then I put the line so it's clear. I'm going to now total these things and write down. And total these things and write down. Like a line when you're adding a bunch of things up. Okay, so what is 15y minus 12y? What is the left side? That's just 3y, isn't it? And these are gone. So what's left on the right side?
17.
Just that 17. See how it's clear there? Last step is always? It'll always be divide. Yeah, the last step to get y alone, because that 3 is multiplied by the y, right? It's right next to the y. It's times. The opposite of times is divide. So now remember what divide means, a divide, like a fraction. And whatever you do to one side, got to do the other. You got to keep the balance. If they were equal before, treat them the same. They'll still be equal. These cancel. And what's the other answer? 17/3. That makes sense on that. Questions on that one? All right, now, how are we doing? Okay, we only got 20 minutes. We got to get...
I thought class ends at 8.
No, 8:15. I got a little more for your money. All right, let's take a look at number 14. 14's got fractions. Y over 2. Yeah, I'm going to put that one on a fresh screen as well. Let's go. Let's do for y over 2, y over 3, 7 over 5. 14, y over 2, y over 3, 7. Did I write that down right? I think I did. Let me see. Y over 2, y over 3, 7 over 5. Yeah. All right. This one's harder. Okay. So this is going to be important. This could be a huge deal in this class. Is fractions, especially how you deal with fractions in an equation, equal sign. Here's what you want to do. So multiply the top. So this is step number 1. Multiply the top of every fraction by 2 times 3 times 5, which equals 30. So I take those 3 denominators, 2, 3, and 5, and I times them all together and get 30. 2 times 3 is 6, 6 times 5 is 30. So I'm going to multiply the top of every fraction by 30. Watch what I'm not going to do. Here's the mistake that a lot of people make on this kind of problem. They'll come in and they'll go, okay, 30 is the common denominator. I know about common denominators. I'll multiply the top and bottom of this one by 15. That'll make it 15y over 30. That's true, but that's going to be way harder. You do not want to do it that way. So everybody hear me on this? It's really important that you see not to do that. Why not? Because you might think, I've done that before. I know that it's true. There is a time when you do it that way. It's when you don't have an equal sign. So I don't want to overly confuse you, give you too many details right now. But let me give you this fact. When you have an equal sign, you need to start forming in your brain the difference between problems with equal signs and problems without equal signs. Equations, equal signs, and expressions, things that don't have equal signs. Meaning, what if somebody just gave me a problem like this, and they said, so maybe I will use a little bit of time. They just said, hey, I want you to add y over 2 and y over 3, and y over, or 7 over 5. I want you just to add those up, please. Is there an equal sign there?
No.
So that would be an expression. That would actually be a pretty different problem. Even though it's got the same 3 components, they're related differently. Do you see that? You need to have a category in your mind that says equal sign problem, not an equal sign problem. Different worlds, different actions. When you have an equal sign, all of your thinking should be left, right, left, right. I got an equal sign, left, right, left, right. Here, no equal sign, no left, right. Don't think left, right. You can't do left, right. There is no left, right. Well, then what are you going to do? Top, bottom. So it's early. We'll have whole sections on this later. But let me plan in your mind even right now. In math, we're always keeping the balance, and there's 2 ways to do that. Top, bottom, or left, right. Well, how do you know which one? If you got an equal sign, left, right. If you don't have an equal sign, top, bottom. Make sense? If you have an equal sign, left, right. So that's why I say, don't do this on an equal sign problem. Because what's that? That's top, bottom. That 15 is the same thing on the top and the bottom, and I got an equal sign. I shouldn't be doing any top, bottom on an equal sign problem. All of my work should be left, right, not top, bottom. I'm not going to mess with the bottom. It's going to be way easier. Let me show you. So you don't do top, bottom. That is, by the way, what you would do down here. That would be correct down here. You would have to do the top and the bottom, and that would be right when there's no equal sign. But when there's an equal sign, You don't do, what do? You multiply them all together, get your 30, and what are you going to do with that 30? Top only. Top only. Top only. Is that okay to do the top only? Yeah, because I'm doing the same thing to the two terms on the left as I did on the right. I'm treating the left and the right the same. They're equal. If they were equal before and you do the same to the left and the right, they're going to be equal afterwards. You don't have to do the bottom. You can do anything you want. Do you feel that freedom you have with an equal sign? If two things are equal and you add a million to both of them, they're still going to be equal, right? So we can do anything we want. When you have an equal sign, as long as you do it to all the terms on the left and all the terms on the right, it's true. They'll be equal afterwards. And so this is going to be way better. You just do the top. We're not thinking top bottom at all when we have an equal sign. All of our thinking is left, right. Equal sign left, right. Okay, well then what? Well, you actually know, huh? We did some of these earlier. Let me move this out of the way a little bit. Whoop, that wasn't helpful. So what do we do now when we have this 30 multiplying y over 2? What do you do when a whole number, yeah, we're going to divide, huh? What do you do when a whole number is interacting with a fraction? Put it over 1 to make it look like a fraction, and then cross cancel, divide. 2 goes into 30, huh? Just like we were doing earlier. 2 goes into 30 how many times? 15. And they're gone, right? See me drawing that line through them? They're out of there. What's left on that left side? 15 and y. Over 1, but I don't need to do over 1. That's nothing. Plus, can you do the middle one? Same thing. Yeah. Because the 30 is over 1. And 3 goes into 30. 10 times, huh? 30 divided by 3 is 10. 10, and the y is still there. My right is a little sloppy here. Let me put that y back in a little better. The y is still there. But the 3 and the 30 are gone, aren't they? 10y. Okay, can you do the right side? That one's a little harder. Finish up the right side. So again, you put the 30 over 1, right? Whenever a whole number interacts with a fraction, put it over 1. Cross cancel and multiply whatever's left over. Use your calculator if you need to. 5 goes into 30. 6 times. They're both, the 5 and the 30 are gone. They canceled. What's left is the 6 and the 7. 6 times 7? Yeah. Look what we have. No more fractions. So much better. That's why we do this on the first step whenever we have fractions. The rest is going to be easy. I'll do it with you, but that's the major step. You make it through there, the rest is going to be easy. Do you see what happened there? So when you have an equal sign with fractions, you multiply them all together, get the LCD means least common denominator, that's the LCD, and then you multiply the top of each of them. Not the top and the bottom. That's what you do when you don't have equal signs. So with the equal signs, we're not thinking top, bottom, we're thinking left, right. See that difference? Okay, so let's finish the problem from there. So what do we do now? Keep the wall clear. Can you finish it? Let me let you finish it from there. So, oh, it reduces, doesn't it? That's right, I didn't think about that. Yeah, wait, does it?
No.
Oh, no, it doesn't.
That's a fraction.
Yeah, so add those together, 15y, 10y, 25y. And then the last step is always?
Division.
Yeah, divide by whatever's next to that y. Y wants to be alone. Yeah, I don't think that one reduces, huh?
No.
That's just it. Yeah, oh, by the way, a good question was asked. Yeah, what about the top being bigger? Doesn't matter. It's totally fine. Don't change it to a mixed number. They want you to leave it like that. So just leave it just like that. And we're done with that one. Does that make sense how you handle fractions with an equal sign? It's this step. Multiply them all together, get the common denominator, top, 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 and cross cancel them out of there. All right. Yeah, Dennis. Yeah, we're going to do tests. All right, let's go back. Where are we at? 15. We did 15, huh? So 16, 17, 18. These are more of the same. They're good.
Oh, yeah, you said that there's going to be multiple choice, right?
Let's do 19. Yeah, and yeah.
Oh, then I'll know what I'm doing.
All right, so number 19. Let's try that one. Yeah, that'd be good. Let's follow with 19 right now. Y over 6, Y over 4, 6 over 7. Okay. Let's do 19. And then we'll go back if we have time. We probably won't. Y over 6, Y over 4, 6 over 7. y over 6, y over 4, 6 over 7. So what are you supposed to do in the first step when you have fractions with an equal sign? Multiply the tops by 6 times 4 times 7, right? Really, you don't even have to figure out what that number is. Who cares what that number is? Just go over here and write 6 times 4 times 7. And 6 times 4. This will actually be easier. Times 7. And 6 times 4 times 7. I don't even care what that number is. And that'll be really useful in weeks to come when they're letters. And we have to put them that way. So let's just get in that rhythm right now. You don't even need to figure out what the number is. Just put the whole thing top, top, top. 647, 647, 647. Right? Okay, and now what do? Put it over 1, cross cancel, multiply whatever's left over, use your calculator at that point. We don't care what that original number was. We just have to use them all. Does that make sense? See how that's using all three denominators? 6, 4, 7. So, what have we been seeing? What happens with the top and the bottom of a fraction? Cancel, right? So what's this 6 going to cancel? The other 6. And they are gonzo. So what's left?
The 4 and the 7.
And what's 4 times 7?
28.
28. You should calculate if you're rusty on some of those. See that? That's the same thing you would get if you got the big old whopping number and divided.
And you cancel.
Dividing is just canceling.
And then you do the same way with the next one.
Same thing, same thing. Just keep going. All right, so let's take a look. So again, how do we deal with denominators with an equal sign? We take all the denominators, all of them, top, 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 don't we? And it's going to be the same thing when we get to letters. So all the denominators, the 6, the 4, the 7, top, top, top. Please write it this way. You're going to need to, don't do the big numbers. You're going to need to know this way in weeks to come with letters anyway. You're going to have to do it this way. So write them top, top, top. And don't write them off to the side or somewhere else. Put them right by the fractions like I did. Okay, now what's left there? So notice these 6's canceled. And what is left is 4 times 7 times y, 28y. Okay, what happens here? The 4's cancel. What's left is 6 times 7 times y, 42y. Okay, now here's the right side. This is what's getting people a little bit more is the right side. Okay, now just do the same process. Now, a good question was asked. Somebody said, hey, should we cancel the 6's? That's a good question. No. Why do those 6's not cancel? They're both in the top. You only cancel stuff under the bar with stuff over the bar, huh? Those two 6's are eventually going to multiply. They're not going to cancel. They're both in the top. So what does cancel then? The 7 with the 7. And what's left over? All of these, including two 6's, huh? 6 times 6 times 4, 144. Now you just add these up. What's that? 70? 70? Yeah. 70y is 144. Last step is always... It's always easy once the fractions are gone, huh? Divide by 70. Now, you do have to reduce something like that. You got to divide by 2, top and bottom. You know, if something goes in, you have to reduce. Now, most of the calculators that any scientific calculator you bring next time, I can probably show you how to do it automatically. They'll do them automatically now. But you have to know how to do it, and I can show you. You just type in 144 over 7, hit whatever button for whichever type of calculator you have, and it'll automatically make it, 72 over 35?
Yeah.
And that's the final answer.
Yeah.
72 over 35.
Why you have to divide it by. But that's what I just wanted.
Oh, it's just simplifying it. Now just 2 goes into both of them. You just got to simplify it.
The right answer is with even numbers you have